So I think the best way to describe it is a virtualization layer. A virtualization layer that encompasses both memory device, byte addressable device, SSD device, and present it to the application either as a file system or as a memory extension. Okay, if your application needs IOPS or low latency storage, it can achieve that using this virtualization layer. And if it needs a memory extension, it needs to experience a very large memory that spans over memory and physical storage device, it can experience experience that as well. How does all that fit within the software stack? Let me, maybe I'll try to do it on the board. Where's the black marker? Oh, there you go. Thank you. So let's say that we have a memory device, and I'm not going to define specifically if it's non-volatile DIMM or traditional DRAM. It doesn't really.
It could be either.
It could be either. We don't care. It depends on your application. If you need persistency, you're going to use NVDIMM. If you don't care about persistency, you're going to use DRAM. So we don't care. The point about this device is that it needs to be byte addressable, meaning we can access a certain byte, modify the byte, read the byte back. We don't need to work at a block granularity. There is no I/O operation when we are dealing with a memory device. That's the main theme for a byte addressable device. The second tier, the extension for that, will be a traditional SSD. Traditional SSD works at the block level. It needs to erase a block, read a block, modify a block. That's the resolution. In order for application, eventually, even for the kernel, to access an SSD device, you need to copy the data first to memory, make the modifications, erase the block on the SSD, and write it back. This read, modify, write is pretty much the basic concept within traditional storage. We decided to take it out of the equation. And what we've done was marrying memory and SSD together with the virtualization layer on top that we are calling SDM, software-defined memory. I'll explain in a minute why we think software-defined memory is the right term for such a technology, and exposing that either as a huge memory extension to the application, okay, memory extension, or as a POSIX file system. So if your application is a MySQL application and it's doing a lot of reads, writes into a database file, it's going to use this API and will benefit from the performance of memory and the capacity of SSD. And if your application needs a huge memory, needs to allocate a huge memory to work on, and you don't have enough physical memory on your machine, it's going to use that API, and it can experience a memory that is a composition of this tier and this tier. So we can actually provide you a 2 terabyte of memory-like device. It's not going to perform completely at memory speed. It's going to perform at near memory speed, but the experience is going to be, it's going to be byte addressable.
So do applications have to be rewritten to take advantage of this API, or do you do something else?
So the answer is no. And the reason for that is that POSIX is a standard.
Okay, but
every
that's
application.
Only one option. The other option is the memory extension.
Exactly. So the question is, how do applications like Cassandra and MongoDB and Redis allocate memory? And the API for that is mmap, memory map. That's the API. It's a POSIX API. And the moment we've implemented the mmap function, every application, Redis, Mongo, Cassandra, InfluxDB, any kind of application that wants to allocate a huge amount of memory is going to use this API, and we're going to provide it through that API.
Okay, so you're actually still, even if it's a memory extension where an application needs to get a big chunk of RAM, you're still going to use the POSIX route to get that.
Exactly.
Okay.
That's the traditional route that applications are using in order to allocate memory.
So for Cassandra, you're going on the left, or Mongo.
Right.
Or if you want to write your own potentially and are willing to embrace the Nmap driver.
Exactly, exactly. Now,
Conceivably,
applications...
you could run HANA and
That's exactly the case.
talk to the memory interface.
Right, and get...
That's exactly the case.
So Sharon, can I ask a question?
Sure.
I have a virtual infrastructure. I'm loading up this tool into it so that I can address the enormous database that I want to just put into one of those VMs. How exactly is this built? What does it look like in terms of my infrastructure? Does it load as a VM? Does it load as almost a component of an individual VM? or a component of the ESX server itself? I really want to understand
Absolutely.
the architecture.
Absolutely. So I'm going to erase that and make a mental note about SDM. I'm going to explain it in a few more minutes. So how does a deployment of Plexistor actually looks like? So Plexistor is a pure software solution. It's actually a kernel module that gets inserted into the Linux operating system. And the reason we're doing that is so we can have a direct access to the physical storage devices, either memory or SSD, and at the same time to be below, quote unquote, the application. Okay? We need to get stuck in the middle between the application and the physical hardware underneath. So how does it actually looks like? I've got the RAM. I'm sorry, I'm gonna try today make it bigger. You know, for me it looks big.
Wow.
So I'm going to have a RAM device, okay, and I'm going to have an SSD device. There is some kind of a driver on top of the RAM. It's called PMEM. This is what Linux is providing. This is not ours. This is the standard Linux. On top of the SSD, you've got the BIO driver, okay? All of that is part of the Linux kernel, okay? And you've got your application on top. Plexistor is getting inserted right here in this layer. This is where Plexistor is sitting, okay? From your perspective, Plexistor, it actually looks like a device driver. Right. It's a device driver, that's what it is. Consuming the physical hardware underneath and exposing it back as a file system. From that perspective, if you want to run KVM, okay, and I'm specifically picking on KVM, KVM is going to run here, and you've got all your virtual machines on top. Okay? Through KVM, of course, all the virtual machines can benefit from the high-performance file system underneath KVM. Okay? In the case of VMware, that cannot be done. We cannot support VMware because VMware is a closed operating system. In order for us to deliver a driver for VMware, we need to engage with VMware and develop a specific driver for VMware. That's not an easy task to do. We'll keep it for a later time.
But this sits at ring point 5, just above the hypervisor. Between the hypervisor and the hardware.
And the operating system, exactly. Exactly.
But not up in the individual VM.
No, not in any way.
It's a shared resource.
It's a shared
amongst the
resources.
VM.
It's called a sub-hypervisor implementation.
So you could have 100 VMs thinking they each have 10 gigs of RAM, and it
While
would
they
all
don't.
sit on an SSD.
Right, exactly.
Yeah,
You took it to the extreme, but the concept is yes.
Yeah,
The
that's
answer
what
is
I'm trying
yes.
to say, yeah.
part of me says, so you've written virtual memory drivers that actually work as opposed to the ones actually in the operating system.
Yeah.
Yes, but absolutely true. Absolutely true. The difference is that we are bringing storage concepts into the game. That's the twist.
Look. There's the floor wax, the file system that it's a micro-tiering file system that uses RAM and is NVDIM aware, and that's cool.
By itself.
But that's storage acceleration. And then there's the virtual memory that isn't so slow that it makes me want to kill myself.
Correct.
Which is a really cool dessert topping.
Right.
So
I put in Plexistor and then I have some SSDs and somehow I configure that in a way to say this is how much memory you have. Is that accurate?
So it doesn't physically look like memory. I mean, but when the application wants to allocate memory,
Yep.
okay, it's going to ask for a certain API, and the API will experience a very large memory storage.
Which is why it's supporting Cassandra and MongoDB, things that already do
MAP
that.
functions.
Yeah, exactly.
Okay.
Exactly.
So it depends on what you say when you mean application.
So in contrast to Diablo, when you're actually looking at the system and the BIOS is even saying, oh, now you've got 2 terabytes of memory because of memory 1,
Yep.
which is a totally different solution and it's a great approach. In our case, that's not what you're going to see.
Okay.
The system is going to boot up and the BIOS is going to say, oh, we've got 64 gigabytes, and that's what it is. But because we are tweaking the underlying infrastructure, we are combining SSD and memory. When the application is going to ask for memory, it's going to get a huge chunk of memory.
and since you keep referencing Diablo, that SSD could be ultra-dim.
Absolutely.
Yeah.
By the way, it can also be memory 1. If your case is ephemeral, it can also be memory 1.
Yeah.
So you could use either Diablo Probo. And one of the things that gets me excited about this is because that could also be another kind of memory that Intel isn't ready to talk about as well.
Right.
That's going to soon take the entire data center by storm, looking for a way to be used.
Well,
And now you've seen a way that can be used.
Yeah. So you said before that there's a file system interface to it as well. So I
Correct.
can actually write to it using file things.
Absolutely.
But I'm assuming that won't be the same space as the area that I am mapped into, say, Cassandra.
So the idea is not to physically determine how much is allocated for memory experience and how much is allocated for the file system experience, I'm calling it, okay? It's the same space exactly.
Yep.
You're gonna create a file and you can map the file. So the abstraction area is always files, okay? You can create a file of 1 terabyte and you can now ask the system to map the file to the memory and you're going to experience a 1 terabyte memory experience. But you have a file that represents that surrounding this memory chunk or giving it some kind of meta information. You see what I'm saying?
Kind of.
So-
So I can kind of basically say
You
this
can
is a
basically-
RAM disk, sort of. Well, it's not really a RAM disk. It's a disk RAM that I say, here is a file, here is some disk RAM, go nuts, and use this as memory.
Exactly.
That's very cool.
Okay. Now take it forward. You want to copy this file or memory chunk, quote unquote, to another machine. You can do it. It represents itself as a file. You can copy a file over the network to another machine. It gives you a very high level of flexibility how to manage those kind of applications.
So you mentioned before that you have a replication capability to
Correct.
another node. So is that for like an HA type replication experience, or is this so that you have a more of a global allocation space across multiple physical servers?
So this is where I said earlier, once network is involved, you are going to degrade performance.
Yes.
Our philosophy is that a certain application will use a certain storage and it needs to be local to the application. The concept is that all the data the application is going to need ever is going to be completely local. And if it's not, we're going to make sure that it is going to be local. We're going to collect the data, bring it locally to the machine, okay, and making sure that everything is localized in order to achieve near memory speed. The purpose of HA, for example, is to create availability.
Yeah.
So we are replicating the data from one machine to another. Again, later release of the product. But in this way, you can create a symmetric copy of the data on another node. This node fails, the other node can come up to live.
So that's clustering.
That's
Sort of.
HA.
That's HA.
That's HA.
It's HA.
How do we,
Not
let's go under the presumption that we could cluster by 2 VMs sitting on the same host. Obviously, your network latency is going to be completely diminished because it's not going across the network and back.
Correct.
You're still going through the network driver, though, so you will be introducing a whole bunch of...
Of course, there is
latency.
some, but there's no cabling involved.
That's true. So I'm going to elaborate.
I think the order of magnitude versus
Just one
the
second,
CPU
let me
talking
answer
to
this question,
memory,
then you
as
can
soon as
elaborate
you-
on it a bit more.
Of course,
As soon
you're
as you
going
go
to
out
get a
to
hit.
something...
So the simple answer for that is, you're right. I mean, if this VM is creating a file on the Plexistor file system, and this VM wants to access it too, it can. This is why
Simultaneously.
continuously. It's a sub. This is the difference between a sub hypervisor solution versus inside VM solution. All the applications, all the processes, quote unquote, and a VM is a process, can access the same file system as if it was local to them.
And would the, say, the second machine in this mythical cluster that we've just created get its own sort of delivery of Plexistor memory, or would it share the same aggregate?
It will share the same aggregate.
Okay.
Okay. You
And
wanna
can this go in any Linux distribution, or is there just going to be certain distributions?
So our sensitivity is to the kernel version. Currently, we're supporting Ubuntu, we're supporting CentOS, we're supporting RHEL. We're trying to support the main releases, and the reason for that is actually the QA matrix. We're trying to, save resources.
So, how is it licensed and how much?
So the licensing mechanism, right now, the first release is completely free. You can download it, you can play
like
with
that.
it.
Yeah.
Free is good.
It's hard to
Free is
make
good.
profit that way.
Excuse me?
It's hard to make a profit that way.
You don't. It's not hard. You don't.
Dropbox is just figuring that out.
Yeah, I saw the move. But you're absolutely right. I mean, free, and it's not open source. I need to say that. It's free for the purpose of seeding the concept of SDM, software-defined memory, to the market and to show.
I thought it was free like the first nickel bag.
Huh?
I thought it was free like the first nickel bag.
You're going to say Nickelback.
So you were going to explain the term software-defined memory.
I'm just going to answer the business model because
Sure, sorry.
the first release is completely free because it's a very limited release. It's a share nothing configuration, meaning you don't have a clustering configuration, you don't have HA, you don't have snapshots, you don't have cloning, deduplication, compression. All the features that we are used to as an enterprise storage guys are not there. The purpose is to show sheer performance. Okay. And what's shipping out as the first release is just the file system component itself, okay? The solution itself is a converged solution. It's got containers there and management and Kubernetes and the whole 9 yards, okay? But what we are shipping now is just a file system. We think it's not enough to massively engage the market. It's a great way to taste the benefit of software-defined memory concept.
Jerome?
Yes.
Stop calling it the first version, start calling it the public beta.
Public beta, that's a good term. I'm accepting that. It's a great way to experience the performance.
Go back.
I think, so the next release actually that we are planning to provide the market is actually going to be subscription-based. Okay, it's not a perpetual license, it's a subscription and the price is per node, per year. And it doesn't matter what the kind of CPU you're going to use, how much memory is going to be in the machine. We are trying to change the pricing model for storage technology, not to make it per capacity, per gigabyte, or per IOPS, or any other sophisticated, per vCPU per day. So that's about the pricing. I want to elaborate a bit
Tell
about.
us how many zeros?
What?
You said it's per machine per year. I know you're not going to tell us the exact number, but can you tell us how many zeros?
3.
Thank you.
It's not that complicated, actually. The price is not that we're trying to make it reasonable, and the reason pricing is a complicated thing. You need to think about the alternatives. If Plexistor is going to cost you $20,000 and the alternative is to buy DRAM, you're going to buy DRAM. Okay, you're not going to buy Plexistor. So we need to find the right balance between price and value. What is SDM and why we are calling it SDM, software-defined memory? If you remember software-defined network, the concept behind software-defined network was that the provisioning of the network is done out of band. Okay, you're defining the circuit, okay, defining the destination or defining the path of the routers, and data flows directly from the source to the destination. That's the basic concept of SDN. We took exactly the same philosophy, and what we are saying is that you can provision the storage out of band. You're provisioning the access to the storage out of band, but when an application is actually trying to access the storage, it's doing it directly. Okay? We are managing this entire virtualization layer out of band, and this is why we are feeling comfortable calling it software-defined memory. You can control, what's the memory experience, what's the file system experience, and how data is actually flowing. Does it answer the question about SDM?
Yeah.
Okay.
Sounds like it opens to other questions.
It's possibly a personal taste thing. I find the term a little confusing.
Okay.
But then I find the term software-defined networking, I'm not a fan of that either.
Okay.
I think my issue with it is that it doesn't actually give me any new information. It actually confuses me more.
The SDM
Like, it
concept?
doesn't answer a question.
Yeah, and it only describes the memory interface. When you call it software-defined memory, it doesn't describe the file system
Right.
interface at all.
Right,
Yeah.
I agree.
Which is a shame because it's...
rather than, for the exact meaning of software-defined memory, virtual memory that doesn't suck would be clearer.
So I don't think it needs a new term because we have some things that are already kind of analogous that people know and understand well.
Right.
That you could then use that and say, well, it's kind of like these things, but it's different in these 2 or 3 ways. And now it's a shortcut, so you don't have to explain more things That's why I'm not a
Yeah.
huge fan.
No, I understand what you're
I can understand why you want to kind of have a label for it to package it up and go, it's this thing. But that's tricky when we don't really. I mean, even now we're still arguing over what a cloud means or what software-defined networking is.
So help me understand. Earlier, you started talking about Diablo, right? And you were
Right.
complimentary, but then there was a part where you said, I think what you said was that if it's a ephemeral configuration, they're fine, but if not, then their solution wouldn't work the way yours does.
Memory one is ephemeral, it's not persistent.
It's just memory.
Just memory, it's memory extension.
Just memory, even though it's flash.
It doesn't matter, they don't maintain
Okay,
state.
it's pretending to be memory. So,
Yeah.
Memory one is slow memory.
but then they
it's
have
cheap.
the other application,
The ultradim,
right?
Yeah.
that's a different thing.
UltraDIM is a
Right.
different.
So ultradim is persistent, okay? And again, it needs to be exposed somehow to the application. This is why ultradim can be an excellent second tier for Plexistor.
Yeah, so UltraDIM is storage, not memory.
Right.
Right.
It's persistent. It happens to be in the memory channel, but it looks like an SSD. It looks like a drive. It looks like a disk drive.
Well, when they first pitched it to us, they said that it would be
Yeah.
in the memory space too, but it turns out that
Yeah.
didn't
Well,
ever.
and memory one seems like it's the same thing, but it's totally different. It's memory.
It's just memory, and it's always ephemeral.
Yeah, on reboot, the system.
Erase, actually.
Erases
Erase
memory
everything.
one.
Exactly.
And as you people are noticing, it's very confusing when you start talking about memory that's actually storage and storage that's actually memory and how they are used and all that.
And I think this is the paradigm that we are trying this is the chasm they're trying to cross. I mean, the mix of memory and storage and the applications that treat memory as storage and storage as memory all became, very blur. Where is the borderline between?
Well, to me, storage is persistent memory, basically.
Right.
And the only reason that we have storage is because memory is not persistent. Because storage is just slow memory.
Right.
If we had persistent memory that was fast, we wouldn't have any storage.
Absolutely agree.
Everything we would never have
Absolutely
done
agree with you.
file
Memory
I/O.
that's fast. That's a
Yeah,
great idea.
we would never have had any block I/O.
We wouldn't invent storage.
Yeah, we wouldn't have invented it because we'd all be using magnetic core still.
Absolutely right.
Yeah,
100%.
But unfortunately, we
not?
can't.
But it's about to get
very
much
much.
more confusing with 3D Crosspoint because that's going to be persistent
memory device.
Yes.
Yeah, well, in
we get to go
many
back-
ways, Crosspoint is returning to core.
Yeah, it's going back to magnetic core,
Absolutely.
which is awesome. We should never have not stopped.
You had a question.
Really just around overhead. It's quite a general question. So running on this on a platform, when you software define a thing, usually you have some form of overhead to achieve that.
True.
Do you? What kind of overhead can you expect on an application server running this? And then similarly, do you have a way to isolate that in terms of resource utilization?
That's an excellent question. We actually found exactly the opposite. The existing storage stack is very much CPU intensive. It can consume up to 15% on a fully loaded system, just the storage stack itself. Because we've reduced the depth of the storage stack, created a very thin layer that goes from the application to the physical storage device, and it doesn't matter if it's SSD or memory. We just took the entire stack out. We've reduced the overload to 5%. So I'm actually giving you back 10% CPU because of that. And that's actually, again, part of the performance improvement that you're seeing. We are freeing up wasted CPU
So I
back
get
to the
loads more
application.
RAM and I get CPU back.
Yeah.
That sounds
What's
quite
not to like?
That's a 110% system.
That's a really good message to deliver next time at an earlier point. I really think it's a compelling model. I really do. And I'm glad that we now seem to all grasp.
Absolutely.